Welcome back to Astrophysics in 10 Micro Lessons. I'm your guide, Carl Sagan, and today we venture into the stellar nurseries to see how stars are born. In the vast silence of space, massive clouds of gas and dust hold the secrets of creation. These are nebulas, the cradles of the cosmos where light begins. You might recognize them as the pillars of creation or the Great Orion Nebula. These stunning structures are the factories that produce every star in our galaxy. In our last lesson, we explored the Big Bang, the origin of everything. Now, we look at what happens when the universe's raw materials begin to cluster. How does a cold cloud of gas transform into a brilliant, burning sun? These molecular clouds are enormous, often hundreds of light years across. They are composed mostly of hydrogen and helium, seasoned with a tiny fraction of cosmic dust, the remnants of stars long dead. Usually these clouds are stable, but if something disturbs them, like a nearby supernova's shockwave, gravity begins its slow, relentless work of pulling the material together. The shockwave compresses the gas, creating areas of high density. In these pockets, gravity takes over, pulling more and more material toward a central point. It's a titanic battle. Gravity pulls inward, trying to crush the cloud. Gas pressure, created by the heat of compression, pushes outward. For a star to be born, gravity must win. As the cloud collapses, it fragments into smaller clumps. At the center of one of these clumps, the density and temperature start to skyrocket. We call this a protostar, a star in the making. Stars are rarely born alone. A single massive cloud can give birth to hundreds or even thousands of stars at once, creating what we call an open star cluster. The protostar is not yet a star. It's heated by the energy of the collapse itself. It's glowing hot, but the core isn't hot enough for the ultimate transformation yet. For millions of years, the collapse continues. The core temperature reaches a staggering 15 million degrees Celsius. At this point, something miraculous happens. Nuclear fusion. Hydrogen nuclei are crushed together with such force that they fuse into helium. This process releases an incredible amount of energy, creating the outward radiation pressure that finally stops gravity's collapse. A balance is reached, hydrostatic equilibrium. The star ignites, clearing away the remaining dust and shining out into the dark. A new sun has joined the cosmic community. To recap, stars are born in nebulas when gravity overcomes gas pressure, leading to the ignition of nuclear fusion. One cloud can forge an entire cluster of new suns. In our next micro lesson, we'll look at the main sequence, the long, stable life of a star like our sun. Join me then on James's Physics 101. Master the cosmos, one lesson at a time.